Okay, so a lot of you have been introduced to solving equations in the past and to different levels, okay? In grade 9, we try to set you up for solving equations in grade 10, where they get harder, in grade 11, where they get harder, and in grade 12, where they get harder. And we like to show you a system that's going to work no matter how hard the equations get, okay, when they involve trigonometry, when they involve quadratics, okay? We try to get you to have a really good system in grade 9 so you can keep applying it as you move forward in math, okay? So even though you may know the answer in your head, working through the algebraic steps is going to help you when stuff gets harder in grade 10, okay? And even in grade 9 when stuff gets harder. All right, so an equation means that both sides are equal, so start off by knowing that, okay? And so the big rule is whatever you do to one side, you have to do it to the other to keep the sides equal, okay? Whatever you do to one, you have to do it to the other or to keep the sides equal. Solving an equation involves getting x by itself. We saw that with our activity, okay? By performing inverse operations, okay? Inverse, some people think opposite, inverse, opposite. Operations to both sides of the equation. Both sides so important, okay? And then we're just going to talk about what the inverse operations could be, and some of them are probably obvious to you, and other ones maybe you haven't thought about before. But the inverse operation of add 3 would be subtract 3. Add the off your phone, please. Opposite of subtract 5. Charlie? Add 5.
Add 5.
Opposite of multiply by 2. Divide by 2. And here's what I want you to think of. Or multiply by a half. Oh. So if you have 6 divided by 2, if you have 6 times 1/2, what do you end up with both ways? 3. Okay, so dividing by 2 and multiplying by half are both inverse operations of multiplying by 2. Interesting. Opposite of dividing by 5. Multiply by 5. Squaring 16, so putting 16 to the power of 2, that means. What would be the opposite of squaring something? That we want to undo to the power. This is one you might not have thought of before.
Square root.
Square rooting, good. Square root 16. Okay? And if I want to, so this is what 16 squared, and we want to square root it. Square root of 9 looks like this. How would we undo square root, do you think?
You square it.
You square it. These are inverse operations. Nice. Square root, which is power of 2. So those were the two that I was thinking, probably haven't thought about much before. But these are inverse operations. Square and square root are inverse operations. So important techniques for solving equations. We want to isolate x using reverse BEDMAS. So we didn't really talk about that when we were solving equations. But when you were working with your ones first, okay, adding and subtracting to both sides, that was dealing with the addition and subtraction first, and then we spread them out and divided, okay? So we started off with undoing the addition and subtraction, then we undid dividing and multiplying. The only thing that kind of doesn't make sense when we talk about reverse BEDMAS is if there's brackets, we expanded them first, okay? So we did still expand brackets first, so I'm going to put a little star here, but expand brackets first. Create zero pairs to undo addition or subtraction. We were getting very good at that by the end. Okay? Use division or multiplication to create a 1 in front of the variable. You want to know how much one of it is worth. That's your whole goal. Okay? When the variable is on both sides, so you have a 3x on one side and a 2x on the other, perform the inverse operation on the smallest one. That way you'll have a positive number of x's on the other side instead of a negative number, and it's always easier to deal with positives. When there are brackets, you need to expand them first. We already talked about them. So those are important techniques, and we'll just stop there. All right, so the first one I want us to model and do together is x plus 74 equals 13. So off your phones, looking at the first one here. So just like in the activity, the idea is to figure out the value of 1x, okay? And remember, we had 0 pairs to work with, inverse operations, reverse BEDMAS, creating a 1, all that stuff. So, who thinks they know what the first step would be for this one? And I'll show you how to show it. Yeah, subtract 74 on both sides. Okay, and that's exactly how you show it vertically. Okay, so you're showing that underneath. Okay, and then now I'm going to show that I know that's a 0 pair by crossing it off. Okay, so now we're going to say what's left on the left side of the equal sign is x now, and on the right side I have to get my brain or my calculator and do 13 minus 74 negative 61. Okay, and now I know that just x means 1x, so now I know that 1x is negative 61. Okay, I'm going to leave the next one for you guys to do, then we're going to go on to this one. 2x minus 7 equals 5. Who thinks they know what the first step would be for this one? This one. 2x minus 7 equals 5. Add?
Yeah.
Add what?
7.
Yes, add 7 positives to both sides. Perfect. So that's how you show it, okay? We're also looking at how you communicate it. So I see some people have the add 7 underneath the 2x. Why would I not put it there? Because I'm matching up like things, right? So negative 7 and positive 7. To show that I know it's a 0 pair, I'm going to cross it off. So now what's left on this side is 2 x's. And what's left on this side is 12.
So 1x equals 6.
Good. And the way we show our thinking is really what we did is we divided them in 2. So we divided by 2 on both sides, and we're going to use that vertical division bar, not this, right, 7 and 8 divide sign. Okay, we're going to use a vertical division bar. And notice we made a 1, because what's 2 divided by 2? 1. So 2 divided by 2 is 1x, and 12 divided by 2 is 6. So that's how we show that thinking. Do I need the 1 in front of the x? No, you don't need it, but if it's there, it's not wrong. Okay? So 1x equals 6 is the same thing as x equals 6. Okay, so we're really focusing on, you guys kind of got the logistics of it, we're really focusing on how to write it down now. So we're going to go over to the one right below this one here. Negative 2x plus 6 equals 3x plus 36. Negative 2x plus 6 equals 3x plus 36. So we're focusing on this one. So to get x by itself, it has to be on one side only. Okay? To start getting x by itself, it has to be on one side only. So if we look back at our rules here, when x was on both sides, it says when the variable is on both sides, perform the inverse operation on the smallest. So let's decide what's smaller, negative 2x or positive 3x. Charlie, you two are sitting together, but you have to stay focused.
Let's subtract.
What's smaller, negative 2x or 3x was my question.
Or negative 2.
Negative 2x is smaller, so we're going to do the inverse operation to both sides. So we're going to add 2x. Notice where I put it on this side. That creates a zero pair. Do you agree? But whatever I do to one side, I do to the other, and I want to line it up with the x's. So I'm adding 2x to both sides. Now I want to show this that I know this is a zero pair, so I'm crossing it off. I know it's a zero pair, so I'm crossing it off. So what's left on this side is just 6 now. On this side, 5x plus 36. Now some people don't like it when x is on the right side. It just bothers them. Okay? It doesn't bother me, but some people don't like it. If it bothered me, could I just do this? Yeah, because what does the equal sign mean? Both sides are the same, right? So it doesn't matter which thing's on which side as long as exactly this is written here and exactly that is written here. So some people do that, some people don't. Some people are just fine working with it the way it is. Okay? If I did switch it, what would I do next? Right.
You would do 0 pairs.
Yep. With the?
36.
Good, because we're trying to get x by itself. I show I know it's a zero pair and cross it off. So what am I left with on this side? 5x. 6 minus 36 is negative 30. Careful with signs. And now I want to split it up into 5 groups, which is really dividing by 5 on both sides. So I show that with a vertical division bar. And then 5 divided by 5 is 1. So I have 1x now, which is what I want to know. The goal is to know what 1x is worth. And negative 30 divided by 5 is negative 6. Okay, negative 30 divided by 5 is negative 6. Okay, I want to target that one. Okay, we're also going to go on to the next one here. 2x equals negative 6 is the next one we're going to look at. Is there any zero pairs I can make here? No. So what would be my only thing I need to show to get the answer? How would I show what 1x is? How do I get from 2x to 1x? You divide by 2. Do you ever divide by x? No, that's a common misunderstanding is people want to divide by 2x. But 2 divided by 2 gives you 1. So now you know that 1x is equal to negative 3. Okay? All right, the next one. I'm going to pause. Okay, so some people forgot to expand the brackets first. That would be the first step. If you didn't ask now, what's the next step you did for this one? Yep.
So you would make 0 pairs at 15.
Good.
So you would add everything to make it 15, and then you do the same for the other side.
Perfect, which gives you?
5x equals 35.
Close.
Negative.
Yep.
And then you divide 5x by 5 to make 1.
Yeah.
And then you do the same for the other side, and then 1x equals negative 7.
Awesome. Any questions? That's exactly what you do with exactly showing your algebraic reasoning there. That's perfect. We're also going to do the next one, a quarter x equals 3. So remember, we've got like a quarter. We know that a quarter of x equals 3. So how am I going to know what a whole x is? A quarter.
3 times 4.
Yes. So I'm going to multiply both sides by 4. So think about this. Really think about it. Whatever you do to one side, you do to the other. So these 4s are my algebraic thinking. Okay? So remember that what's the denominator of a 4 if I don't show one? A 1. So on this side, I end up with 4 times 1 times x, 4x, over 1 times 4 is 4. And over here, I end up with 12. But 4 divided by 4 is 1x. So I figured out what 1x was by multiplying by 4. Okay? So this is just showing my reasoning, and the picture helps too, for that one. Okay? The picture I find helps a lot of people when they're trying to figure out fraction ones. Okay? What's the next one we're going to do? We're going to go to x squared equals 9 here next. So if we look at x squared equals 9, and we said to undo squared, we do square root. So we're going to do square root of x squared equals square root of 9. So we did the same thing to both sides. I'll actually do these things in red, like I usually do. Same operation to both sides. So square root undoes squared is the inverse operation. So if I take the square root of x squared, it equals x. Okay, so square root undoes squared. So square root of x squared is x. Square root of 9, we've got either a brain or a button on our calculator that can tell us the square root of 9. That's squared. Square root 3. Okay, so try to find that button again. Refresh your memory. You haven't used it in a while. Find the button and make sure you can use it. Square root of 9 is 3. Okay? Square root of 9 is 3. Okay, and the last one we're going to do together before we go and finish all the other ones on the whiteboards in pairs is this one here. So square root of x equals 5. How do I figure out what 1x is? What's the inverse of square rooting? Squaring, and this is how I would show it. Squaring both sides. So there's my algebraic thinking, the red brackets with the squared. Okay? If you square the square root of x, it undoes square root, so you're left with 1x. And if you square 5 times 5, 25. Okay, so I'm going to pause it for now. We're going to go back. So just starting off, I'll fill these in for the people at home that everyone was good with adding 33 to both sides and crossing off your zero pair. And that gives you 51. This one was very well done too. Most people showed subtracting x on both sides to get the x just onto one side. And then subtracting 6 on both sides. And showing your zero pair. And then dividing by 2. X equals 2. This was the first one where we had trouble, okay? So I saw lots of groups trying to add 5a to the other side, but that doesn't help matters. So basically on one side of the equal sign, you've got, and I drew a picture over here, but I'll draw it again. Actually, I'll draw it on here so that folks at home can see it. So really you've got 2 positive a's and negative 5 a's all on the same side, right? So that's 2 zero pairs right there, and you've got negative 3 a's left on this side, or when you collect like terms, I heard a lot of tutors say, on the same side, 2a minus 5a is negative 3a. So all I did was combine them, okay? Then I had minus 2 still on this side, equals 7. Then once that was figured out, everyone was pretty good about adding 2 to both sides and dividing by negative 3. That was another place where I saw groups struggle. They divided both sides by 3. But what would happen if you did that? Just to think about it, you always want to make a 1, but negative 3 divided by 3 isn't 1. It's negative 1. Okay, so always check yourself on that. So you always want to make a positive 1. And this one, this is the sneaky negative, I call it. Okay, so a couple people were caught on that and then they went back and fixed it. X is on this side, so you always want to start, if X is only on one side, you kind of start on that side. Okay, and you see, what can I do? Well, I can create a zero pair, and then test yourself. If you're not sure if it's a zero pair, 2 minus 2, make sure it's 0. You can do that, okay? You can think that through. Is 2 minus 2 0? Yes. So do it to both sides. Now that sneaky negative is still in front of the 2x, okay? So you can't forget about it. 14 minus 2 is 12. And then I want to make a 1. So what's the negative 2 doing to the x? It's multiplying. So the inverse operation is to divide both sides by negative 2, and you show it with that vertical division bar. And 12 divided by negative 2 is negative 6. Okay, and that's the value of 1x or x. Okay, 1x and x are the same thing. This one here, I think everyone did really well on, so I don't think I'll take that one up. This one, a couple people had trouble making the zero pair. I saw a plus 8 first, so you can test yourself. 8 plus 8 is 16, not a zero pair. And this is the side with x, so that's the side I'm working with because I want to get x by itself. So negative 7 minus 8, a couple people got negative 1 for that, but it's negative 15, good. And then they check themselves. Okay, so x equals 15, negative 15 equals x is the same as x equals negative 15. This one, I saw a lot of people turning it around like this, which was fine, okay? I like to think of this one with the picture. So a third of x, so 1/3 of x, or x over 3, has 11 in it. So we know already that a whole x is going to have 33 in it. How do we show it algebraically? You show multiplying both sides by 3. Whatever you do to one side, you do to the other. Okay, and this is like having a 3 over 1. So if you multiply the tops together, you get 3x over, and you multiply the bottoms together, 3 equals 33, but 3 divided by 3 gives you that 1x that you want. You always want to create a 1 in front of the x, positive 1, because you want to know the value of 1 of the x's. This one was really well done. People are getting into it now. So they knew they had to do that first. And same on this side. Careful. Some people had negative 8x plus 1. They forgot the negative 4 times by the negative, but negative 4 times by the positive 1. A smaller number of x's we're going to work with. So negative 8x is smaller than 3x, so we're going to add 8x on both sides to create a zero pair. So there's my zero pair. And again, ask yourself, is it creating 0? Is negative 8x plus 8x 0? Yes. And don't forget the x's. I saw some people just writing plus 8 plus 8. That's not right, because you can't add 3x and 8, because they're not like terms. Okay? So now on this side you have 11x minus 15. On this side you have negative 4. Now the side with x is the side that tells you what to do. It's the side that bosses you around, so it's telling you to get x by itself. You have to add 15 to both sides. Negative 4 plus 15 is 11. Now we want to divide both sides by 11. And we get x to be 1. This one, straightforward. Subtract 71 on both sides. So 2 x's is negative 52. Thank you. And then divide both sides by 2. And you get x equal to negative 26. Okay. This one, what's smaller, negative 2x or negative 6x? 6. 6 is more negative. So add 6x to both sides. And that's going to give me a positive number of x's. It won't be wrong if you do it the other way. X will be on the other side and it will be negative. But as long as you do everything else right, you're good. So negative 2x's and 6x's is 4x's. now it becomes this question. X is only on this side now. I want to get it by itself. So I have to add 12 to both sides. 4x equals 16. Now I have to get what 1x is, so I'm going to divide both sides by 4. I meant to do red there. And we get 1x is 4. Okay, this one tripped people up again too. What do you do when the x's are on the same side of the equal sign? You combine them, correct? So really on this side I have 5x's. Does everyone see that? 7x's minus 2x's is 5x's. This is my side with x, so it's telling me what to do. I want to do the opposite of multiplying by 5, which is divide by 5. So I've got x equal to 6. What's smaller, 10x or negative 3x? Negative 3x, so we're going to add 3x to both sides. Look where I'm putting it, right under the x terms. I'm showing that I know like terms as well there. So on this side now I have 13x's. Now the side with x is the boss, tells me what to do. 13x equals negative 65. And you divide both sides by 13, you get that 1x is negative 5. This one, most people subtracted 7 first, which was awesome. So that gives you x over 4 is 6, which I create a picture in my head for. So there's 4. We know a quarter of x is 6. So I already know a whole x is going to be 24. My situation becomes, how do I show my algebraic thinking? Okay? So if you think of this as x divided by 4, the inverse operation is to multiply by 4. So you want to multiply both sides by 4. And you think of that as 4 over 1. Multiply the tops together, the bottoms together, and then realize that 4 divided by 4 is 1x. Okay? Pictures really help for the fraction ones I find. Because you know what the answer is going to come out to be. You can figure it out. And then the inverse of dividing is multiplying. Okay, did any groups get to this one? If you're someone that got to it, what was your first step? Okay. All right. This is a side with x on it, so it's bossing us around. You're going to subtract 8 on both sides and check and make sure you've made a 0 pair. 8 minus 8 is 0. 3 is the square root of x. How do I undo square root? Who remembers? Squared. Good. So I show that. Squared. Squared. So I figure out 3 squared on my calculator. And squared undoes square root, so 1x is 9. Okay? And then this one's similar. This is a side with x, so it's bossing me around. Create a 0 pair on this side. So I've got x squared is 16. And then the opposite operation of square is square root. And then if you do that on your calculator properly, you'll get x to be 4. Okay, square root of 16 is 4. All right, this one's a cool one. We can draw a picture. So we know 3/4 of x, if we fill in 3/4, it's 6. There's another color here. 3/4 of it's 6, and you want to know what a whole of it is. What's one way to think about it? If 3/4 of it is 6, what fits into each little quarter? 2? If 3/4 of it is 6, that means that there's 2 in each one of these. Does that make sense? So there's gotta be 2 in this one, so we know the answer has to be 8, okay? The way I like to think of this one is how can I make a 1 in front of x? So if I multiply by 4/3, what happens in front of x? I'm going to get 12x on top and 12 on the bottom. And 12 divided by 12 is 1. So I've made a 1 by doing that. By multiplying by the reciprocal, I've made a 1. But if I do that on this side, I have to do it on this side. Do you see that? And we know we're going for 8. We know we're going for 8 there. Okay? So we get our 12x over 12, which we know is 1x. That's what we want. 4 times 6 is 24 if I multiply the tops together. And if I multiply the bottoms together, I get 3. Okay? And I know this is 1x, because 12 divided by 12 is 1. And then I'm going to check what's 24 divided by 3? 8, which is what we reasoned through that it should be, right, with our picture. So I call this making a 1. Multiplying by the reciprocal is making a 1 to go in front of it. Making a 1. Okay? So we know what 0 pairs look like. That's what making a 1 looks like for a fraction question. And I think that's, see it? Yeah, okay, so that's the end.